Feel the surge, jump into the future, it's time to emerge. Lilypad Network, we're here to stay, taking you on a journey in a groundbreaking way. We're the frogs in the net, powering AI with the dubstep set. Lilypad Network, watch us rise with the beat that grooves, the tech that defies. Lilypad Network, let's dive in deep, connecting the world. One leap at a time with epic drops and foggy vibes. We're making waves. It's our Lilypad Network ride. Drop the bass, feel the surge, jump into the future, it's time to emerge. Lilypad Network, we're here to stay, taking you on a journey in a groundbreaking way.
All right. Hello, I'm Devlin from Lilypad, and I'm DevRel over there. Today we've got Stanley on board. We're going to be talking about some things that he's working on. I'm going to bring him on the stage. Hello, Stan. How you doing?
Hey, doing good, my friend. How are you today?
Awesome. Happy to talk to you again. Friendly neighborhood AI scientist. I love that. Little tagline.
All right. It's important to stay friendly. And honestly, too, I feel like it's a good vibe because a lot of this stuff is pretty crazy. And, thinking about how, it affects communities, our neighborhoods, it's a good part to remember. So, yeah, I do that character. And, yeah, some cool stuff to talk about today. But you having a good week so far? Or?
Oh yeah, and a good weekend also. The extra day yesterday was huge. MLK Day. It's a really important day. But yeah, I love what you said, because I think AI doesn't just affect our neighborhoods, but it's eventually going to affect like all of society. In my opinion, it's going to really change the way that that our society functions. I think it's going to just revolutionize so much. So doing it in a friendly way is definitely ideal, right? Because it can be used for nefarious purposes too, right? With great power comes great responsibility and all that.
Yeah, totally. And also in addition to just the vibe, which I think is very important, trying to find ways that AI can be used for good is so exciting. And Lilypad supports a lot of research in that area. And, I think keeping AI decentralized and, democratic is a really big part of making sure it's applied in good ways. And very fun stuff. We have some of that to talk about today.
Absolutely. And open source is another huge, stay on the good side of AI. But yeah, you got any news that you wanted to share about? You said you want to talk about the results from O3, right?
Yeah, I thought it could be good to start a little topical. And yeah, we had some really big news this week. Maybe that's a good place to start. Have you spent much time talking to the new O1 Pro?
No, I don't have the Pro subscription. That's a little too expensive for me. But I do have O1 Preview and Mini that I use quite often. But yeah, so tell me about O3 or O1 Pro.
Yeah, well, O1 Pro is this model that OpenAI is gating behind their new $200 a month subscription. And so it's representing a big jump forward in what they're offering. And very interesting because I think the situations where you'd want to use O1 Pro are very different than when you would want to use some of their other models. And it's interesting. It takes quite a while to run. It needs a little more time to think than we've gotten used to with our basic models. And yeah, the reason why is it is going through a system of thought where it isn't just one model being queried, but it is not just a number of models being queried, but using models to guide the process of thought. So, for example, if you were requesting from a model that, this would be what people talk about when they talk about an agent system. You might have one model that's asked to structure the chain of thought that's needed to solve a problem. So if you're asking it to help you plan a materials list for your camping trip, it might write a bunch of questions that are needed to kind of get the right material. And then it might have another model that reviews that output and maybe goes, oh, you should add this, you should add that. And then maybe it dispatches each question to a different agent to look up and write down what materials would be needed, and then maybe those, et cetera, et cetera. And this is obviously me just doing kind of a caricature of what is almost definitely a very complicated system. But yeah, this is the kind of thing that OpenAI is now offering in their O1 Pro system. And yeah, also an example of what people are talking about when they're talking about agents lately. It seems like it's been the big topic.
Nice. Yeah, that's and the simple answers are much appreciated. Because like you said, this is all super convoluted, complicated stuff, but just having the baseline knowledge and being able to understand it is obviously really important. So simple answers are much appreciated. But yeah, that's really interesting. So previous to O1, you may not know this, or maybe you do. That'd be great. But previous to O1, talking to ChatGPT was just a single model, and so with O1, they're actually using multiple models to create this chain of thought that you're saying. That's really interesting. It seems like it could be incredibly powerful for a lot of different use cases too, more than just text generation.
Yeah, absolutely, and it's pretty interesting. Like I would say, the kind of problems that you want to tag in that deeper thought to solve. So yeah, it's been very interesting because it does take quite a bit longer to run one of the queries. Sometimes I'm using other models to create the prompts that I'm giving this deeper, more thoughtful system. But yeah, very, very cool stuff, and really cool seeing that new product from OpenAI. But yeah, even more interesting is what we've started to hear about their what we believe to be their frontier internal model, which is O3.
Okay, so yeah, tell me about O3, because I've heard of O1. I think a lot of us have it. There's $200 a month pricing, and I think made a big splash for a lot of people. But I haven't heard much of O3. So is this recent news? Is this new, or can you tell me about it? Some kind of
well, it's an internal model at OpenAI. It's their sort of like current frontier model in the O family. I believe that is kind of their post ChatGPT rebranding of their high-end model offerings. What happened to O2, you may ask?
That's a good question.
It turns out there is a branding conflict for just O2. I think there's some, maybe Virgin owns some company named O2, like a news channel. So yeah, they jumped over 2 to 3, and yeah, 3 is one of these new kind of chain of thought models, like O1 Pro, but the scale is substantially different. I believe they shared that for these O3 models, a single query costs $5,000.
Wow.
In compute, and it's yeah,
that's
right.
Crazy. That's jaw dropping.
Careful hitting that button, right?
Yeah.
But great question, and one that kind of relates to what we're going to be talking about today is like, what is that cost? Like, what is costing so much? Is it that they're running models that are like a lot bigger than the models other companies are using? It actually is not that at all. It's the number of models they're running, and the fact that they have these models talking to and interacting with each other.
So do you think that this is sort of what we'll see a lot more moving forward, is instead of focusing on larger and larger models, we'll start to focus more on the chain of models talking to each other?
Well, this is really what everyone's excited about with agents, that we're moving past kind of single model optimization and application and into systems of models that do things and have missions, and what we would sometimes call agency, that we would call them an agent system. And it does very much look like that's kind of the direction we're going in this field. But I would say it kind of isn't about how big or small the model is. It is more about, is it the right model for the job? And we actually are learning that, just like humans, machine intelligences can be different from each other in many, many different ways. And there's kind of an emerging, dare I say, artistry to understanding how to put these pieces together.
That's really interesting, especially when we think of the end goal for AI for a lot of people is the AGI, right? That can do everything. So it's kind of interesting to hear you talk about these more specialized models, the right model for the job. That it's it almost feels like a departure from that. How do you feel about that? I'm not sure. I can explain
Oh,
more if you think.
well, I actually, when we were planning for this topic, I mentioned that this model was in the news because OpenAI beat a very famous and important benchmark. But I don't think I told you the benchmark. It is the ARC AGI benchmark. And
Oh,
so that is all of the top people in the world got together and they said, what is a set of problems that we could give an AI? And we all agree that if it beats 80% on this exam, it is an AGI.
wow. So O3 is the first to pass that test.
I believe O3 got like 84%. So
Wow.
very strong finish. And pretty shocking and kind of like exciting. But yeah, it really does look that with these kind of system of thought AI topologies, they are pushing the envelope all the way past what we had best described as an AGI level intelligence. At the same time, it is interesting, and for the viewer, you might want to go check this out. I'd even say this could be a cool blog post. It could be cool to maybe share some of the details of this. But if you kind of go look at the problems that the AI was given, it's impressive. It's bloody impressive. And if you gave it to a smart person, they might not hit 80. It's pretty incredible. At the same time, it got some problems wrong that no human would ever miss. And so, at least to some degree, it seems to be a different kind of intelligence.
Right.
Um,
That's interesting. That because that's something a lot of people touch on also is the human factor, right? And how a lot of people don't think the AI will ever fully achieve that human factor. Especially when it comes to arts and creation, stuff like that. Poetry, whatever. So how do you think that it'll get there eventually? Do you think it'll eventually we'll be able to program in that human factor and it'll be able to solve those? I'm not sure what problems it was that they got wrong, but do you think it'll eventually be able to reach that?
um,
It's hard to
yeah,
say,
I
right?
wouldn't be at all surprised if they keep struggling to make hard enough benchmarks in general. And I think that the question of like what you can build with human systems and what you can build with AI systems and what you can build with systems that contain both. Because a lot of how they are getting to these systems is having humans interact with them and doing what's known as like reinforcement learning. So I tend to think of it as perhaps like less a thing about the discrete parts and more about the system and how the pieces are put together. But yeah, definitely. Sorry, go ahead.
I was just going to ask if you mind sharing. A lot of people might not know what reinforcement learning is. I'm not too sure myself, so could appreciate a quick explanation and explain like I'm 5.
Oh, absolutely. I'm happy to explain. And this is also the main topic of a cool video Lilypad will be releasing about the project that's the main topic of our discussion. But yeah, reinforcement learning, sometimes you would say RLHF in the context we're talking about, reinforcement learning with human feedback. That's where you actually have a human interacting with the AI in terms of what it's saying or if it is saying the right thing. And then you have a system that actually captures that interaction and feeds it back. So over time, you would see a system that's interacting with a set of like very knowledgeable humans to kind of learn better what those humans are knowledgeable in.
Interesting. Okay. So I had one more quick question, and we can jump into that main thing that we want to talk about today. So I may have actually been wrong earlier. So I was talking about AI hitting AGI through a single model, but you're saying O3 was able to pass the AGI test, and it uses a chain of models. So I may have actually been wrong here in thinking that the AGI would be a single giant AI model, but it's actually maybe it's multiple models chaining together is what creates that AGI network. You have all these different specialized models working in some sort of network together, right? Do you think is that a correct understanding, you think?
Yeah, I mean, you would even say that using just those systems, or I like to call them topologies of thought, OpenAI created an AGI, at least according to the best benchmarks that we have. And yeah, very cool new step for the subject. But yeah, definitely a step where it's fun to kind of slow down and talk about what these AI agent or these kind of system of thought thingies are. And yeah, to that point, we actually in our local builders community in LA, using Lilypad technologies, we just built a very cool agent system. I'm totally stoked to tell you a little about.
Oh yeah, and I'm stoked to dive in. So yeah, feel free. So you're building this with your team down in LA, working on the Lilypad network. What mind sharing with the audience? What I know what it is, but do you mind telling them a bit about what what it is that you're building?
Oh yeah, super happy to. And yeah, we have like a really cool makers community here in LA. And every Sunday we meet at this incredible impact accelerator called the KIN. It's kind of like a co-working space slash startup incubator that works with companies that have some kind of community positive mission. So just like really wonderful network of people over there. And one of my very good friends, who's like a real leader in this community, his name is Vivek, and Vivek is a bioinformatician and a data scientist who does oncology research and compound development for Cedars-Sinai, and works on some really fascinating stuff. And so I kind of work in an adjacent area. So Vivek and I are often doing projects together and kind of collaborating on papers. And yeah, actually, he shared with me a particular pain point in his day-to-day workflows, like kind of his day job. And we were able to kind of study what this set of tasks was that he was, finding onerous, and actually kind of reverse engineer what he was doing in his head, so we could build an AI agent system that would do the job for him.
That's really cool. Hopefully, it saves them a ton of time, right?
Well, this is my hope, because this is one of my really good video game buddies, and it is very hard to catch him on Steam because he's always reading papers. But no, I joke, because obviously, like, helping one of the few like very gifted people working on oncology who we're really lucky to have, helping them stay focused on where they can be doing the most good, which is obviously the patients, is feels like a very cool use of this kind of technology.
Yeah. I hate to break it to you, but I think your friend will probably just find more work to do. He just won't be reading papers. He'll be doing something else.
Oh no, this is why I really do say it in jest, but it's I think a pretty good jest there. So,
Mhm.
but yeah, anyway, to kind of kick us off on this agent system and just telling the audience a little bit more about what we're talking about. What have you heard about immunotherapy?
Immunotherapy. I can't say I know much about immunotherapy, but I'd love to learn some more if you don't mind sharing.
Oh, well, yeah. So, man, cancer is crazy, and when we talk about cancer, it's like good to remember that there really isn't just one cancer. It's there's thousands of different types of cancer that might as well be different diseases. They're doing something totally different to a different part of the body for different reasons, with different effects and different treatments. are helpful for others and not others. So the common factor is that it is a genetic process that has gotten out of control, and the body has a number of different systems that create that whatever that in control means. There's a number of different systems that regulate the resources that certain tissues can ask for from the body. There's systems that are kind of looking for cells that are out of control and then targeting them with things like the immune system. And so for a cancer to develop, it's sort of like the way Vivek says is you kind of have to have a bunch of bad rolls of the dice. Because maybe every hour there's a large number of times when our cells are dividing, like they're doing it right now. Don't think about it though. Sorry.
I'm thinking about it.
No, totally. But where they don't copy properly, and something could potentially kind of replicate out of control. But one system or the other catches it, or it's missing some piece that would cause it to get out of control. So it's really kind of a perfect storm usually when an actual a sustaining oncological process develops. And one of those things that has to go wrong, I mentioned, is the immune system has to be somehow tricked or into not acting against a tumor, or be unable to. It has some way of evading, and so in immunotherapy, it's a pretty broad range of techniques where we're either introducing custom antibodies to actually target the tumor. Like we might actually sequence the tumor and find like a specific protein that we can tell the antibody to target, or maybe we do something to get the immune system's attention focused on the. So it really is a deep practice, and it is one where I support by running the computers. And so I am so excited. I think we are going to have Vivek actually talking about his work pretty specifically. But real point though is it is remarkable the tools that we have to interact in what we would call a precise way. The field of effort that we're talking about here is usually called precision medicine, which kind of means we're trying to see the very specific details of how a biological process, in this case cancer, is happening, and then trying to see if we can disrupt just a certain part, or we can interact with just a certain part to get the outcome we're looking for. And so it really is a matter of like doing this very precise measurement of what's going on in a particular patient, and then connecting that to the right molecules, be they an antibody or a protein or a peptide, or there's really like whole ontologies of different things you could use. But anyway, sorry to ramble. This is just a subject I'm particularly fascinated by. But real point is that staying on top of what those molecular tools are for my friend Vivek's tool belt. Oh my God, are there a lot of papers to read, bro?
I bet. I mean, that's what's something I've always heard about the medical field in particular, is that there's always research. You always have to stay on top, always doing reading, and if you're not constantly doing that research and reading, then you're just falling behind. So, sorry, did you?
Yeah, and some of these papers are just they're so incredible. The fact that people can study this stuff, it's just kind of humbling what humans are capable of. And I'm here watching cartoons this evening, so heck. But
you're the scientist, Stanley.
Oh no, that's a joke, man. I'm just helping the scientists. I'm the computer scientist. But that's so fun though, man. That's why I love this kind of work, because I do get to work with and learn from some just incredible thinkers. But anyway, getting to the point, these papers can be kind of big, and there's so many different levels of science that have to be shared. And so, sometimes just even finding the sections where they're talking about a molecule that could be used in a patient, and then kind of like keeping all of that together in a system. So like when they're working with a particular patient, they can like easily figure out what might be the interesting molecules. That's the set of tasks like we decided to target here. So yeah, I'll just kind of jump off. It was so
Yeah,
cool because what we did is we oh, go ahead. Sorry.
no, sorry, I was going to say when you're talking about breaking down the tasks, 'cause you had mentioned this earlier. I don't know if it's what you're about to jump into, but I wanted to ask. You said you sort of reverse engineered your friend's work process, and so I just wanted to um, hear about that also, and how you're able to reverse engineer that and apply it to an AI agent.
Yeah, exactly. Yeah, so that was kind of what we did is we sat down with our friend and we asked him to walk us through. Hey, you're sitting down to go through a new paper to see if it could be useful in your practice. Kind of step by step. What do you do?
Yeah. And you got to be super thorough, right? Because if it's in, AI is very specific, just like a computer. If you have one wrong step or one step that's like you overlooked because it's just like, it's just something that you always do, then it's going to all fall apart, right? So you got to be very, very thorough with these instructions.
Yeah, and that's part of the exciting part of the process is there's a lot to be specific about, and you get a chance to improve it and kind of work together with the partner. So yeah, in this case, like we were able to define a pretty simple agent system, and basically it's one that tries to automate this process of going from paper to protein. So there are 4 steps, and yeah, it starts with the scientist requesting that the system process a paper, or that's part of the mission here is to enable a lot of papers to be processed. And yeah, it's a pretty cool, pretty simple step-by-step process, and I'll just kind of go through it quickly. But I would say to the audience and everyone out there, good time in terms of the scope of history now that AGI has been created. Crazy to say that.
That's
To
insane.
No, seriously, and it's a good time to learn about the system that did it. It's a good time to be, thinking in agents.
Yeah, honestly, that's probably the biggest takeaway for me. I had no idea that AGI had technically been created. I keep talking about it throughout this live stream as like a thing we're striving for, forgetting that it's been done. It's insane. And I'm very curious to see when if O3 or another model that has AGI reaches AGI when it comes to the public, how that's going to change things. Because already AI has been revolutionizing so much.
No, and listen, people are starting to talk about what will it be like when a lot of jobs start being done by these kind of systems. So like I said, the way that humans interact with them, the way that humans can contribute to building them, really good to start thinking about your thought process in terms of agents, because people are going to be trying to build an agent that thinks the way you think, but also you could be part of building, creating, improving a system that kind of reflects your knowledge. And I think we're all pretty clear this is going to be a bumpy ride, but a system where humans kind of help kickstart different intelligence systems, and then continue to act as the stewards and improvers of those systems. That's an outcome that maybe we could all steer towards. And so, yeah, one of the things that will be really fun to tell you about is we try to, in this process, identify all the places where the AI can show its work to our partner and our friend Vivek, and he can correct it. And the things that he suggests can be fed back into the system by, what we were talking about, reinforcement learning.
Mm-hmm. RLHF, right?
You're absolutely. Oh no, dude, we're so fun to be learning together. And yeah, so anyway, the first step of the process is actually for a first LLM to be asked if a paper should be read. And that model is given a prompt that includes the abstract of the paper, a set of keywords from the paper, a summarization of the paper, and then also the input information about the patient case. So all of that is kind of put together into a prompt, and then the model is asked if the paper should be read. That's the first step. The second step, the papers that pass the first step, a smaller model that is intended to be tuned on a very specific molecular language data set is asked if each paragraph from the paper contains the description of a molecule or a protein.
Of a certain molecule or protein that you're looking for based on the patient, or?
At this step, it is any molecule or protein.
Okay.
We are looking to just kind of take these papers, which could be 50 to 100 paragraphs of many different on many different topics, and they usually contain just a section or a couple paragraphs that are on the molecular and proteomic details. So this model is doing a good job if it basically identifies those molecular design specific paragraphs and then passes them on to the next step in the chain of thought.
Gotcha. So just to reiterate and make sure I'm following, the first one sort of does a quick glance and determines, is this paper worth reading or not based off the abstract and some keywords. And then if they do pass that test, it gives it to the second model, which is smaller. And then that one will actually read the paper and sort of determine, oh, this is talking about this molecule, that molecule, this molecule, and then sort of tag that paper as it's talking about X, Y, and Z. Is that correct so far?
Yeah, totally. And so after, just like you said, the second step of this agent process, we have selected papers from the bigger set of papers that we're interested in. We filtered those papers for paragraphs that have information about molecules and proteins. And now we're going to pass those paragraphs to a bigger model. And then here's one of the really interesting things, and we were talking about this a little earlier. It isn't about the model being big arbitrarily. Mm-hmm. It's about the model being big enough and having the right tuning, supporting data sets, configuration. And so in this case, just giving the whole paper to a single model and asking it to produce what we're going to be trying to get out of step 3, very, very challenging, and I don't think we would do too good a job. Changing that problem by having the smaller model interacting first, filtering down from papers to paragraphs, that task is a much easier task. It obviously is one we have to do at scale, but it is one a relatively small model can do. And so just think about this tweak, like this 4-agent system I'm describing. If we tried to do it in 3 instead of 4, we would have had this one node that would have been very congested and not performed very well. But we were able to kind of split the problem up into 2 pieces, one that could be done by a small model, and then one that requires the bigger model. And yeah, as a result, we get a cheaper, more effective pipeline.
It's like the single responsibility principle from software engineering, except applied to AI agents. So each model has one responsibility in this chain of tasks, right?
Oh, absolutely. And I really can't tell you how much there is a flavor of organization design in this whole thing, because it really is like you're, trying to profile the tasks and then set up systems that can, accomplish the outcomes. And yeah, very cool stuff. And then the last step is that this this model that is our kind of bigger model is now reading paragraphs that specifically contain discussion or description of molecular entities, and then we ask it to read these paragraphs and then write up a sort of report or an output summary that contains two different things. It contains the what we would call the PDB prompt.
What was that? The what?
The PDB prompt.
PDB?
PDB is a file. It's a .pdb file. And a PDB file is the standard file for a 3D protein structure.
Interesting.
Yeah, so one of the most impressive things humans have ever done is the protein databank archive, which if you search for protein databank should come right up. And it is the total of every protein ever 3D modeled or imaged by humanity in the time that we've been here. So it's, I would say, maybe one of the most impressive examples of scientific effort in history. And I'll tell you, before I found this out at my last birthday, I had always been most proud that I was born on the same day as Snoop Dogg, October 20th. But yeah, I did find out actually same birthday as the PDB databank, so even more proud.
Nice, that's awesome. Yeah, I haven't heard about this, and this is a big reason why I love talking to you, Stanley, because I feel like every single time we have a conversation, I'm learning so much. I'm taking all these notes. I have so many things to look up after this and do research on. I always appreciate talking to you and all the knowledge you have to share.
Oh, dude, well, so kind, and I'm sorry, to be rambling. It is one of those weeks when I'm
No,
pushing
you're not
the
rambling.
the brain hard. But dude, I always have so much fun exploring ideas like this. There's just such art to these incredible things that we've learned as a species. Even on crazy times, there is a lot to be proud of in our history. But
Yes.
yeah, anyway, the third agent outputs what I mentioned is a PDB prompt.
Mhm.
And then it also contains a report describing what the understood properties and potential interactions are for this molecule. So for example, if the molecule was an antibody that was being discussed in the context of a particular cancer, the report would say, the attached prompt describes an antibody that is, used in blank case and interacts with blank molecules. And then the prompt is actually, and this is so cool, we've built and customized a text to protein system.
What does that look like?
So it's so fun because it is literally just like Mid-Journey or a Mid-Journey style architecture, or you might also be familiar with Stable Diffusion, is another model that Lilypad has offered.
That's right.
And it is a text to image model. The same way that a model can be trained on text to image by looking at a data set containing images with descriptive text, we can train a model to be able to imagine and create molecular and protein structures by being given just a text description of what kind of molecule or protein we're interested in.
That sounds fascinating. I can't even begin to imagine this in my head because I'm not. That sounds crazy. Do you have any examples of this, like off the top of your head that I can look up?
Oh, absolutely. Well, listen, it is on Hugging Face, the base model that we're using, and I think that if you search for PINAL, that is the name of the model. It is a text to protein model.
Sorry, it was
just
PIN
like AL.
AL. Okay.
And if you have any trouble, I can share it a bit later.
Yeah.
But yeah, this is totally the kind of model that we're interested in offering and supporting eventually on Lilypad, and it's another great example of a brilliant open source developer releasing models on Hugging Face. And part of our goal at Lilypad is to create sources of revenue for those kind of open source creators, because if they want to offer sort of updated and supported Lilypad module, in addition to just, posting their models for free on Hugging Face, they could potentially make a living by just kind of updating and maintaining their models if, there's demand for them.
Mm-hmm. And that's right. And we've got module examples being built, and some actually already built in our docs. We're building a lot more. We've got a lot of module creation news coming soon. So if you guys are interested in building modules, stay tuned. And also take a look at this Hugging Face module. Maybe you can implement that into Lilypad, get some rewards. But we've got a blog out if you want to learn more about the rewards. And also you can, of course, join our Discord. I'll put that link on the screen here. Where is it? Where is it? Somewhere. Oh, I don't think I have the invite in here. I'll have to go create one. But yeah, join the Discord. I'll put the link below in a second, and learn all there is to learn about module creation on the Lilypad. We've got a lot of news coming in the next few weeks. Sorry to take over for a bit, Stanley,
Yeah.
but I'm excited about our module creation
I
stuff.
gotta say, that effort is so exciting, and there's a particular small language model that for this pipeline we're talking about, it had been kind of my dream to start working with it. It's called the Falcon 3 7 billion parameter model.
You've told me so much about this model. I know how much you love it, but please share with the audience about why you love this model so much, or why you want to work with it so badly.
I've chatted with the team a time or two, and it's an incredible team building this model. But I kind of think of it as the first small language model that I would say fully understands the role that small language models are going to play. For example, like in this system, we describe the small language models, the one that's doing the bulk processing of all these paragraphs. The Falcon 3 model uses something called a state space architecture, which kind of makes it a little better at kind of like, from my perspective, I would describe it as remembering the details of those kind of bulk tasks. So that it's sort of more optimized for like this, what I find to be a very common situation where you're trying to simplify a task by adding a small language layer to kind of reduce complexity. So yeah, very excited. We actually just got Falcon 3 published on the Lilypad network, and we'll be, I think, using it for developing this, oncology research pipeline.
That's so awesome. Do we have any idea when the AI oncologist is going to be up and running?
I think we have it running internally. I was just reviewing a video of it processing a couple first papers. There's quite a few different ways to develop it. And, one of the things we're most excited about is actually getting Vivek in the loop, right? So that ends up looking like, imagine he is reviewing the papers that it chose to read in detail, like the first agent step, and he's correcting it if it's wrong. Nice. Or if it misses a paper, or if it picks the wrong paper, he corrects it.
So this is part of the tuning. Sorry, excuse me. This is the part of the tuning. So you're going to introduce him to the mix, who sort of inspired this whole system. You're going to introduce him to it to sort of give his feedback and fine tune the model basically with his feedback of whether or not the model did a good job. Is that what you're saying?
Yeah, exactly. And at each step, there's a different kind of level of performance or output for tuning. So after it's selected papers and it's looking for the right paragraphs, we would have Vivek maybe do a close reading of some of those examples and then produce like a tuning set of corrections. So explaining what paragraphs it missed and why it should have had those papers, or which ones it picked that were wrong and why it shouldn't have picked those ones. And then, with those examples, we can tune that second model. The third model I mentioned needs to be kind of our smartest, biggest model, because it's kind of writing these more scientifically complex reports that we need to be scientifically accurate. So that'll actually be a model that's probably tuned with a lot of different data sets. And, we'll have Vivek work very closely reviewing the outputs of that model. But yeah, 100%, this kind of situation where you're building an agent system, I tend to think of it as kind of getting a bunch of plates spinning and then figuring out who are the right humans to get each plate spinning faster in terms of intelligence in the right way. It's really a fun mix of kind of human collaboration and engineering. And I think we'll be having a lot of fun doing it with this first agent system. But like I said, it's really a good time to start thinking in agents because, like, imagine the following. Like, it might be that if we want the very best possible AI oncology research agent, that we don't need just one oncologist to tune it. We need all of the world's oncologists to unite to contribute to the tuning of the system. But if we do that, who's going to own it? Who's going to make money from it? It really is a problem that demands a decentralized solution. And so this is something I'm very excited about developing over time at Lilypad, a system where a decentralized network of stakeholders can contribute to the human feedback tuning of an agent system. And then they can actually offer that system with monetary incentives on Lilypad. Because, to me, that's just such a cool thing. You could almost have, a professional union sort of be the creator and maintainer of an agent system. And, that might end up being a really incredible way for, a union to support its members and potentially, mobilize their expertise for a much broader range of application.
Yeah, that's really interesting, and that's exactly the type of thinking that we're going to need because for years and years before I got into AI, when I first started reading about it, but wasn't really into the tech industry yet, I've read this really impactful article by Wait But Why about the future of AI and what it had for us, and it just really painted the picture of like we were talking about earlier of how much society is going to have to change if we reach. Well, apparently we have reached AGI, but so when AGI becomes more mainstream, I suppose the amount of factors it can have on society as a whole is huge. And so yeah, people keep talking about how it can gut industries, but what you're saying is a wonderful solution where instead of maybe we take those people off of the front lines doing the repetitive annoying tasks that AI can take over, and now they can work on other tasks such as, and one of those tasks could be being like a steward to the model and making sure it's doing its job and fine tuning it, etc., providing that human feedback.
Hey man, I love the way you put that. And like I said, I think it is a moment where, like, it is hard to keep track of things. And the thing that we can try to do is, like, build positive solutions, like talk about positive missions and like help support people, doing the same stuff. And yeah, I think this is a really cool thing we're exploring. And anyway, my friend, I'm so sorry. I may have to jump just a little early because I have to finish writing up the script for this agent demo. But I'm so excited. I think just in a couple days, we'll be releasing a conversation between me and Vivek, where I kind of walk through this agent we built based on a series of interviews I did with Vivek. And I'll tell you, some really good whiteboarding as well. And then, yeah, we're going to start a process of improving with Vivek in the loop and scaling this kind of cool agent system.
That's going to be it's so exciting. It's going to be so huge. I'm super excited for this AI oncologist. I'll definitely be on the lookout for that talk with you and your friend Vivek. I've heard so much about him, right? So excited to put a voice or a face to the name.
Oh, dude, it'll be such a blast. And I think too, it'll be really fun. Maybe on some of these build streams, we could have different thinkers and leaders from different verticals on, and go through maybe with them some of what they're struggling with. See if we can build an agent to help.
I agree. I think it'd be great to have more people on. You're that definitely. Then more varied people too, right? Like you said, different verticals and stuff. A whole variety, because this is Lilypad. Not just AI, but Lilypad in particular. We have a lot of different use cases and different industries that we can touch on with our network. So it makes sense to get opinions from all these people in their different industries.
Heck yeah, man. Well, I am looking forward to following along with everything in all these areas. And dude, so good to talk to you. And yeah, I'll catch you soon.
All right, Stanley, you have a good one. Thanks for stopping by. I appreciate it.
Oh, you're the best, bro. I can't wait for next time, and take good care of yourself.
That's right, you too. All right, and that's it. That's just me now. Super excited, super stoked for all things Lilypad, all things AI. AI is for sure going to be changing society, and we're here just trying to make it a good change. We are going to make it a good change. Until next time, that's it for the Lilypad AMI. AMI. That's it for the Lilypad AMA. Later, y'all.